Now let's have this example. Determine whether each geometric series converges. So letter A, we have 1 plus 1/10 plus 1 over 100 plus 1000 plus dot dot dot. Now this series converges. Why? Since the common ratio here is 1/10. 1/10 is less than 1. Remember, when the absolute value of r is less than 1, then the series converges. Converges meaning there is a definite sum. Letter B, 8 minus 4 plus 2 minus 1 plus dot dot dot. Yes, this also is a convergent series since the common ratio here is negative 1/2, and the absolute value of negative 1/2 is equal to 1/2, which is less than 1. So since the common ratio is less than 1, then this is a convergent series. Letter C, 2 plus 4 plus 8 plus 16 plus dot dot dot. This time, it's not a convergent series. Why? Because the common ratio r here is equal to 2, and absolute value of 2 is still greater than 1. Now, since r is greater than 1, then this is a divergent series, meaning there is no definite sum here. If the nth partial sum s sub n approaches some number s as n approaches infinity, then s is called the sum of the infinite geometric series. The sum of the terms of an infinite geometric sequence S sub infinity is given by the formula S equals A sub 1 all over 1 minus R. R is between negative 1 and 1, or the absolute value of R is less than 1, where A sub 1 is the first term of the sequence and R is the common ratio. So we use this formula for getting the sum of the terms of an infinite geometric sequence. Now let's have an example. Find the sum of each infinite geometric series. Letter A, 1/2 plus 1/4 plus 1/8 plus plus plus. So here, A sub 1 is 1/2. The common ratio is equal to, we can have 1/4 divided by 1/2, that is equal to 1/2. 1/2 is less than 1, therefore we can get the sum. So the sum of this infinite geometric series is equal to A sub 1 over 1 minus R. Substitute the given values. We have S equals 1/2 all over 1 minus 1/2. This is just equal to 1/2 over 1/2, which is just equal to 1. Letter B, 2 plus 2/3 plus 2/9 plus 2 over 27 plus dot dot dot. Here, A sub 1 is equal to 2. The common ratio R is equal to 2/3 over 2, or that's just 1/3. Using the formula to get the sum of the terms of the infinite geometric series, and then substituting the values, we have s equals 2 all over 1 minus 1/3. Since your first term here is 2 and the common ratio is 1/3. Now solving, we'll have 2 over 2/3 or s is equal to 3. Let's try another example. Let's try this. The concept of the sum of infinite geometric series can be extended to transforming a repeating non-terminating decimal into a fraction. Example, express each non-terminating decimal as a fraction in lowest term. So let's try this non-terminating decimal, 0.44444 dot dot dot. Now, this non-terminating decimal can be expressed as 0.4 plus 0.04 plus 0.004 plus 0.0004 plus so on and so forth. Now, in this sequence, we have the series. The first term is 0.4. This is the second term, 0.04. Therefore, to get the common ratio, we have 0.04 over 0.4, that is 0.1. 0.1 is less than 1, therefore this is a convergent series. Now to get the sum, we use this formula again. S equals a sub 1 over 1 minus r. Now substitute the values, we get this, and we get 0.4 over 0.9, which is equal to 4/9. Let's try this example. 0.63636363 dot dot dot. Notice that here there are two values that repeat, 6 and 3. Therefore, this can be expressed as 0.63 plus 0. Add two zeros since there are two repeating values. So 0.0063 plus add another two zeros. So 0.000063 plus and so on and so forth. Therefore, here our first term is 0.63. Our common ratio will be the second term over the first term. So you have this. That is equal to 0.01. Since r is less than 1, therefore again, this is a convergent series, meaning there's a definite sum. And to get that sum, we use this formula. S equals a sub 1 all over 1 minus r. Now substitute the given values. We have 0.63 all over 1 minus 0.01. That is just 0.63 over 0.99 or simply 63 over 99. Round this to get the lowest term. We have at 7 over 11. Now, please answer activity 2.10. Can you transform me? On page 43 as well as activity 2.14. Find my sum if it's possible on page 48 of your learning package 2. Now let's have problems involving the application of geometric sequence. So try this. The population of a town grows by 15% per year. If the population was 100,000 in the year 2000, what is the projected population to the nearest thousands in 2020? So here, we're given the first term, that's 100,000. Now, the second term will be 100,000 plus 100,000 times 0.15 because it said in the problem that the population grows by 15% per year. So, on the next year, which is represented by A sub 2, there will be a 15% increase in the population. And A sub 2 will therefore now be equal to 115,000. Now, what is the common ratio here? So, the common ratio will be equal to 115,000 all over 100,000, which is equal to 1.15. Now, using the formula, A sub n equals A sub 1 r raised to n minus 1, we can have A sub 3 equals 100,000 times 1.15 squared. How did we get this 2 here? Since n is 3 here, so 3 minus 1, therefore that is 2. Therefore, we will have A sub n equals 100,000 times 1.15 raised to n minus 1. Now, what is this n? Now, our n here will be equal to 21. Why? Because there will be 21 terms because from 2000 to 2020, we have 20 years. Okay? Plus the original 100,000, which is the starting population. So therefore, the number of terms here will be 21. So, A sub 21 will be equal to 100,000 times 1.15 raised to 20. 20 because n minus 1 is equal to 20. Therefore, A sub 21 is equal to 1,636,653.739 or approximately 1,637,000, correct to the nearest thousands. Therefore, the projected population in 2020 is 1,637,000. Let's have another problem. A certain bacteria culture doubles in number every day. If there were originally 12,000 bacteria, how many will there be after 15 days? Okay, so let's identify the given. Here, the first term is 12,000, so that's our A sub 1. After 1 day, the bacteria will double. Therefore, A sub 2 will now be 24,000. After 2 days, it's going to double up again. Therefore, A sub 3 is 48,000. So, what is R here? The common ratio here is 24,000 over 12,000. That is 2. Now, what is the general formula here? So, A sub n will be equal to 12,000 because A sub 1 is 12,000 times 2 since the common ratio is 2 raised to n minus 1. Now, what is our n equal to here? How many terms do we have here? After 15 days, therefore that's 15 already, plus the original 12,000, the starting population of the bacteria. Therefore, our n here is 16. There will be 16 terms. So, A sub 16 will be equal to 12,000 times 2 raised to 15. That will be equal to 393,200, 393 million 216,000. So therefore, there will be 393,216,000 bacteria after 15 days. Let's have another example. A car originally priced at 685,000 depreciates at a rate of 12.5% per year. How much will it cost after 5 years? So here we're given a sub 1 to be 685,000. That's the original price of the car. After 1 year, it's going to depreciate at a rate of 12.5%. Therefore, after 1 year, its cost will now become 599,375. After 2 years, it's going to depreciate by 12.5% again. So it will be 524,453.125. Now, what is the common ratio here? R here will be equal to 0.875. Now, let's get the formula. So here, substitute the values. So we have a sub n equals 685,000 times r raised to n minus 1. But what is n? What's the value of n? How many terms are we going to have here? Now it said 5 years. So that's 5 plus the original value, which is 685,000. Therefore, our n here is 6. So a sub 6 is equal to 685,000 times 0.875 raised to 5. That will be equal to 351,342.62. Therefore, it will cost, or the car will cost 351,342.62 centavos and 62 centavos after 5 years. Now, this concludes our lesson on geometric sequences and series. Now, you may now answer activity 2.15, Solve Me, on page 49 of your learning package 2.